Alrighty, let's go ahead and get on started. So, last time we set up our basic zombie. So let's go ahead and see what we have right now. So if we go ahead and start, got a guy that can walk around, some running, punch, equip a weapon, slap with it. Okay, that's all good. And rotate whenever you're attacking with the mouse, not when we're moving. Next up, we have a zombie who has animations and walks towards us. And if we get into attack collider, he'll start beating the crap out of us. And let's see. Yep, so that does damage. Right now I have the spatula set to basically his health damage. So if we slap him, he'll die. Just like that. And his collider is still there. We can push him around, so we might want to disable that on death. But yes, so now up on the agenda, this is kind of where we have to make some decisions. A lot of the times when you're working with games, it's kind of like hard to know what to do next. So one way to look at it is kind of just making it as it comes through your head. So the first thing I can think of besides fixing the zombie is having its navigation set up. So today we're going to be really diving into Unity's nav mesh system. So let's go ahead and look into this. So alright, we need to create a nav mesh to define an area of your scene within which a character can navigate intelligently. To create a nav mesh, do the following. Select the scene geometry where you want to add the nav mesh. In the inspector window, click add component, select navigation, nav mesh surface. In the nav mesh surface, specify the necessary settings. For details on the available settings, refer to the nav mesh surface component. So let's go ahead and open that. When you're finished, click Bake. The nav mesh is generated and displayed in the scene as a blue overlay on the underlying scene geometry. Whenever the navigation window is open and visible, you can bake the nav mesh again to update it each time you make changes to either the scene geometry, nav mesh modifiers, the properties of the nav mesh surface component, or the settings and select page. To currently remove a nav mesh from your project, do one of the following. Click Clear, delete nav mesh. Okay, so here we go. Nav mesh surface component reference. So let's actually just go ahead and start here at the top. AI navigation. Navigation system allows you to create characters that can intelligently move around the game world. That is what we want. These characters use navigation messages that are created automatically from your scene geometry. So these navigation messages are used in a good bit of games. One that comes right to mind is actually the Elder Scrolls Skyrim. I know that uses nav meshes, and if Skyrim does it, then this game should be able to utilize it, especially since it has a simple scale. So dynamic obstacles allow you to alter the navigation of the characters at runtime, while nav mesh links let you build specific actions like opening doors or jumping over gaps or down from a ledge. This section describes Unity's navigation and pathfinding systems in detail. So the following table describes the main topics of AI navigation package documentation. So what's new? Upgrade, convert your projects to... So let's see what's changed in the latest version. Don't even know what's in the latest version. Upgrade, convert your projects to work with the new navigation. So let's see if we are able to. So navigation, handled by as of Unity 22. So we're using Unity 6. So this should already be baked into our thing. If your project uses the nav mesh surface and all that, then remove those scripts and any associated files before you add the new AI. Okay. We don't need to really worry about this. So navigation system in Unity. So the inner workings. When you want to intelligently move characters in your game, or agents as they are called in AI circles, you have to solve two problems. How to reason about the level, to find the destination, then how to move there. These two problems are tightly coupled, but quite different in nature. The problem of reasoning about the level is more global and static, in that it takes into account the whole scene. Moving to the destination is more local and dynamic. It only considers the direction to move and how to prevent collisions from the moving agents. Navigation system needs its own data to represent the walkable areas in the game scene. The walkable areas define the places in the scene where the agent can stand and move. In Unity, the agents are described as cylinders, so that's kind of good because we're working with capsules. So there's our agent. You can kind of see how this works. Nav mesh, move around that. The walkable area is built automatically from geometry in the scene by testing locations where the agent can stand. Then the locations are connected to a surface lying on top of the scene geometry. This surface is called the navigation mesh. Nav mesh for short. The nav mesh stores this surface as a convex polygons. Convex polygons are a useful representation since we know that there are no obstructions between any 2 points inside a polygon. In addition to the polygon boundaries, we store information which polygons are neighbors to each other. This allows us to reason about the whole walkable area. Alright, so finding paths. To find a path between the locations, we need to map the start and destination locations to their nearest polygons. Then we can start searching from the start location, visiting all neighbors until we reach the destination polygon. Tracing the visited polygons allows us to find a sequence of polygons which lead from the start destination. A common algorithm to find a path is A star, pronounced A star, which is what Unity uses. I've actually implemented A star before. So basically how it works is, so these polygons could be seen as nodes, and it will just go out to each of these nodes, checking its neighbors, and using some heuristic values, such as the Manhattan distance, which is the destination minus the location of that node, just kind of point us in the right direction. So it'll keep branching out like this. If we want to visualize this, it's our visualization. See if we can find a little GIF or something. GIF. So pretty simply, if we look at this, this is actually a pretty cool way to do it. He can draw in little obstacles. So if we wait for this visualization, there you go. You can see how it branches out everywhere, but it has heuristics. So once you saw kind of he drew that line, it would branch out everywhere, and then once it found its way with anything uninterrupted, it could just dart right to it, just like that. Okay. So following the path, sequence of polygons which describe the path from the start to the destination is called a corridor. The agent will reach the destination by always steering towards the next visible corner of the corridor. If you have a simple game where only one agent moves in the scene, it's fine to find all the corners of the corridor in one swoop and animate the character to move along the line segments connecting corners. When dealing with multiple agents moving at the same time, they will need to deviate from the original path when avoiding each other. Trying to correct such deviations using a path consisting of line segments soon becomes very difficult and error-prone. So basically, if you have one agent, they will walk in that line, but if you had multiple, they would try to basically walk in the same direction, and they could start bumping into each other, or they could overlap. It would not look too good. Since the agent movement in each frame is quite small, we can use the connectivity of polygons to fix up the corridor in case we need to take a little detour. Then we quickly find the next visible corner to steer towards. Alright, so avoiding obstacles. The steering logic takes position of the next corner, and based on that, figures out a desired direction and speed or velocity needed to reach that destination. Using the desired velocity to move the agent can lead to collision with other agents. Obstacle avoidance chooses a new velocity which balances between moving the desired direction and preventing future collisions with other agents and edges of the nav mesh. Unity is using reciprocal velocity obstacles RVO to predict and prevent collisions. Pretty cool. So moving the agent. Finally, after steering the obstacle avoidance, the final velocity is calculated. In Unity, the agents are simulated to use a simple dynamic model, which also takes into account acceleration to allow more natural and smooth movement. At this stage, you can feed the velocity from the simulated agent to the animation system to move the character using root motion. Let me go ahead and grab that. So root motion is the motion of the character's root node, whether it's controlled by the animation itself or externally. Or let the navigation system take care of that. Alright, probably we'll go with that, but you never know. Once the agent has been moved using either method, the simulated agent location is moved and constrained to nav mesh. This last small step is important for robust navigation. Alright, so next up, global and local. One of the most important things to understand about navigation is the difference between global and local navigation. Global navigation is used to find the corridor across the world. Finding a path across the world is a costly operation requiring quite a lot of processing power and memory. Yes, that is very true. The linear list of polygons describing the path is a flexible data structure for steering, and it can be locally adjusted as the agent's position moves. Local navigation tries to figure out how to efficiently move towards the next corner without colliding with other agents or moving objects. 2 cases for obstacles. Alright. Many applications of navigation require other types of obstacles rather than just other agents. These could be the usual crates and barrels in a shooter game or vehicles. The obstacles can be handled using local obstacle avoidance or global pathfinding. When an obstacle is moving, it is best handled using local coordinate obstacles avoidance. This way, the agent can predictively avoid the obstacle when the obstacle becomes stationary and can be considered to block the path of all agents. The obstacles should affect global navigation, that is, the navigation mesh. Changing the nav mesh is called carving. The process detects which part of the obstacles touches the nav mesh and carves holes into the nav mesh. This is a computationally expensive operation, which is yet another compelling reason why moving objects should not be handled using collision avoidance. You can use local collision avoidance to steer around sparsely scattered objects too. Since the algorithm is local, it only considers the next immediate collisions and cannot steer around traps or handle cases where an obstacle blocks a path using the coordinates. So there's shortcuts and then voxels is the last step. So we'll see about shortcuts between positions or nav meshes. The connections between the nav mesh polygons are described using links inside the pathfinding system. Sometimes it is necessary to let the agent navigate across places which are not walkable. For example, jumping over a fence or traversing through a closed door. These cases need to know the location of the action. You can annotate these actions with the nav mesh link component, which tells the Pathfinder that a route exists through a specified link. Your code can later access this link and perform a special action as the agent follows the path. So, immediately what I'm thinking is, eventually I think zombies are going to be able to come here and attack these windows and then create their own openings into the place. So that might be used as a nav mesh link. So next up is voxels. The nav mesh bake process uses voxelization to build the nav mesh from arbitrary level geometry. The algorithm first rasterizes the scene into voxels, then it extracts the walkable surfaces, then finally turns the walkable surfaces into a navigation mesh. Voxels are cells in a regular 3D grid where the scene geometry overlaps with that grid. The grid cells have a width and length of voxel size and a height that is half of that width. To increase the accuracy of the resulting nav mesh shape, reduce the voxel size so that the 3D grid can rasterize finer details from the scene. So to increase the accuracy, we need to reduce the voxel size, but we don't want to reduce it too much because that's probably going to computationally be very expensive. When the mesh surface uses a small voxel size, it generally creates a nav mesh more slowly than when it uses a large voxel size. You want to create the nav mesh faster, you can no longer reduce the number of scene objects to process. You can increase the voxel size. With that modification, the resulting nav mesh matches the scene geometry with lower accuracy both at the edges, around objects, and in the elevation relative to the ground. To extend nav mesh surface through narrow passages such as doors and maintain a quick baking time, choose the voxel size such as 3 voxels fit 1 agent radius, 6 per diameter. The nav mesh surface uses this size by default. For big open areas, use 1 or 2 voxels per radius, speeds up baking. Tight indoor spots are better suited for smaller voxels, for example 4 to 6 voxels per radius. More than 8 voxels per radius does not usually provide much additional benefit. So voxels is basically going to how we're going to be applying these. So let's see, about agents. So nav mesh agent is a game object that represents a upright cylinder whose size is specified by the radius and height properties. So basically, I think this is going to be attached as a child to our player object, such as the mesh, and just make it the size of the player. And the cylinder moves with the game object, but remains upright even if the object rotates. The shape of the cylinder is used to detect and respond to collisions with other agents and obstacles. When the anchor point of the game object is not at the base of the cylinder, use the base offset property to specify the height difference. Height and radius of the cylinder is specified in the navigation window, and the nav mesh agent component properties of the individual agents. So in the window settings, we can describe how all the nav mesh agents collide and avoid static world geometry. To keep memory on budget and CPU load at a reasonable level, you can only specialize one size in the big settings. Makes sense. And then nav mesh agent component properties values describe how the agent collides with moving obstacles and other agents. Alright, so typically you set the size of the agent with the same values in both places. However, you might have a heavy soldier, you give a heavy soldier a larger radius so that the other agents leave more space around your soldier. Otherwise, your soldier avoids the environment in the same manner as the other agents. Cool. So, obstacles. So if we see this here, nav mesh obstacles can be found in nav mesh agent's navigation during the game in 2 ways. When carve is not enabled, the default behavior of the nav mesh obstacles is similar to that of a collider. Nav mesh agents try to avoid collisions with the nav mesh obstacle, and when close, they collide with the nav mesh obstacle. Obstacle avoidance behavior is very basic and has a short radius. As such, the nav mesh agent might not be able to find its way around an environment cluttered with nav mesh obstacles. This mode is best used in cases where the obstacle is constantly moving. Carving. When carve is enabled, the opposite carves a hole in the nav mesh when stationary. When moving, the obstacle is an obstruction. When a hole is carved into the nav mesh, the Pathfinder is able to navigate the nav mesh agent around locations cluttered with objects or find another route. The current path gets blocked by an object. It's good practice to turn on carving for nav mesh obstacles that generally block navigation but can be moved by the player or other game events like explosions. So carving is going to be important for later. Definitely want to star that or something. I'm going to go ahead and bookmark this page as well. Unity bookmarks. We're going to put that in Unity bookmarks. It's in here. Okay. Okay. Logic for moving nav mesh obstacles. You need to treat the nav mesh obstacle as moving when it's moved more than distance set by the carve is greater than move threshold. When the nav mesh object moves, the carved hole also moves. However, to reduce CPU overhead, the hole is only recalculated when necessary. The result of this calculation is available in the next frame update. The recalculation logic has 2 options. Only carve the nav mesh obstacle is stationary. Carve when the nav mesh obstacle has moved. So, only carve when the nav mesh obstacle is stationary. This is default behavior. To enable it, tick the nav mesh obstacle components carve only stationary checkbox. In this mode, when the nav mesh obstacle moves, the carved hole is removed. When Nav mesh obstacle has stopped moving and has been stationary for more than time set by carving. Time to stationary is treated as stationary, and the carve tool is updated again. While the nav mesh obstacle is moving, the nav mesh agents avoid it using collision avoidance, but don't plan paths around it. Okay. Navigation areas and costs. Alright, so the navigation area defines how difficult it is to walk across a specific area. This is important for finding the path with the lowest total cost. In addition, each nav mesh agent has an area mask, which you can use to specify which areas the agent can move on. So this seems like pretty important. So basically, you can put like a navigation area. This will give it different weights for our A-star pathfinding algorithm. As you can see, these are the different nodes right here, these little polygons. And if the weight is, let's say, 10 in an area, but 1 in the other, it could prioritize going around if that weight never reaches that threshold. For instance, if back here was, let's say, there's 10 nodes along this way, and you could cross this node with a weight of 10, then it would probably, you could pick random. If the water was weight 11 and that was weight 10, then it would pick the other path, and if vice versa, then they would go through the water. Alright, so you can actually read that right here. The water area is made more costly to assign a higher cost to deal with the scenario. So navigation area right there, water. You can assign the area type to every item in the navigation, and each nav mesh link has a property to specify the area type. Okay. Pathfinding cost. In a nutshell, this cost allows you to control which areas the pathfinder favors when finding a path. For example, if you set a cost to an area to 3, traveling across that area is considered to be 3 times longer than alternate routes. To fully understand how the cost works, let's take a look at how the pathfinder works. Alright. So we start right here. The door is not accessible for the agent. We see that right here. I'm trying to get around. So then we can go down, and cost to traverse this link is the distance between the nodes times the area cost of the underlying nav mesh. The shortest route through the A-star graph is this. And there's an A-star node, and that's the destination. Nodes and links visited during... Okay. So we see that. It would make more sense to do that. Okay. So Unity uses A-star to calculate the shortest path on the nav mesh. A-star works on a graph of a connect node. The algorithm starts from the nearest node to the paths start and visits connect nodes until the destination is reached. Since the Unity navigation representation is a mesh of polygons, the first thing that the Pathfinder needs to do is to place a point on each polygon, which the location, which is the location of the short path, is then calculated between these nodes. Since the Unity navigation representation is a mesh of polygons, the first thing the Pathfinder needs to do is to place a point on each polygon, which is the location of the nodes. Shortest path is then calculated for those nodes. So the yellow dots and lines in the above picture shows how the nodes and links are placed in the nav mesh. So you can see right there, there, go right out there. Okay. Which is quite interesting. So the area types, so there's the cost where we can define it like this. Area mask, you can set that multiple area mask. Each agent has area mask, which describes which areas it can use when navigating. The area mask can be set in the agent properties, or a bit mask can be manipulated using a script at runtime. Okay, so getting to the actual overview, now that we kind of just read through, kind of got a little basic understanding of it. So you need to create a nav mesh to define your area. So what we're going to do is pull this bad boy up, like so. And we're going to go ahead and go to our map object, create empty, and we're going to go to see. So select the scene geometry where you want to add. So we're going to go to map. We're probably going, yeah, we're going to select this. We select the scene geometry which you want to add the nav mesh. The inspector will hit add component. And we're going to select navigation. We're going to do nav mesh surface. Alright. And the nav mesh surface component, specify the necessary settings. For details on the available settings, let's go refer to the nav mesh surface component. Right, so we're going here. So let's see, we got agent type, humanoid. Default variable is walkable. Yep, generate links, we don't need to do that yet. Use geometry, render meshes, or physics colliders. I think we want to use physics colliders here. So okay. So agents can move closer to the edge of the physical bounds of the environment with this option than they can with the render meshes option. So I think we definitely want to use physics colliders because every single one of these objects is a physics collider. So we hopefully you can see that if it's flat like this, it's the ground, and if it's up like so, it's a wall. We have trees and such. So there's that. So if I select this has a mesh collider, yes. So there we go. So let's go through these properties again. So nav mesh surface component is fine. Build nav mesh. Yep. And scene nav mesh surface apply it to the game object in which you want to build nav mesh. To apply the nav mesh surface to the game object, do the following: select the game object in the inspector. Select add component navigation nav mesh surface. In the nav mesh, you can bake to generate nav mesh for your current settings and scene geometries. Resulting nav mesh replaces any nav mesh that nav mesh surface already contains. If that's the case, a scene can contain multiple nav mesh surfaces. You can add a nav mesh surface component to any game object in your scene. This is useful for you when you want to use game object parenting hierarchy to define which game objects contribute to the nav mesh. Only the nav mesh surface components that are enabled and part of active game objects load their nav mesh data into the navigation system. You can unload the nav mesh data from the scene by disabling either the nav mesh surface that contains it or the game object that the nav mesh surface is attached to. The following table describes properties. So, alright, subtype of nav mesh, so humanoid. Let's see the other options. We don't have any other options because we haven't made anything, and we are going to just do humanoid. So we got radius of 0.5 and height of 2, it looks like, is the whatever default area. So the area is to find how difficult it is for agents to move across the nav mesh. So walkable, make the nav mesh walk for the assigned agent type. This is the default option. Prevent the specified agent type from crossing this surface unless there is a game object that overrides this type, and jump. This option is used for automatically generating links. Okay. I don't think we want to do that. Automatically generate links between objects. That is the nav mesh surface collects when you bake the nav mesh. If you generate links, nav mesh attempts to generate links between any collected game objects when you bake the nav mesh. If you do not select generate links, nav mesh surface doesn't attempt to generate any links between the collected game objects when you bake the nav mesh. Refer to link generation. So let's see, links generation. Oh, that's not good. Use geometry. Select which geometry you want to bake. So that's render meshes and terrains, and physics colliders. I think we're gonna, yeah, we'll definitely use physics colliders. Nav mesh data, read only, locate the asset file, clear, remove the asset file when the nav mesh is stored, and bake. All right, so there we go, and we can click bake. Navigation is displayed in the scene as a blue overlay on the underlying scene geometry. Whenever the navigation window is open and visible, you can bake the nav mesh again to update it each time you make changes to either the scene geometry, the nav mesh modifiers, the properties. Okay, So let's go ahead and full screen this, and let's just try this out. Alrighty. So we see this. Okay, so it does not seem to have... Alright, so now instead we're actually going to try, we're going to clear that. Let's do render meshes. Bake. Okay, yep. Okay, so I think I failed to do excessive number of tiles. Try limiting this between surface objects or increasing either the tile size or the voxel size. So advanced. We do override tile size. Minimum region area. Alright, so we're gonna override the voxel size. 3 voxels per agent radius. So the voxel size is pretty big, so we're gonna just try generating it on a 3. The voxel per agent is too small. The agent may not avoid walls and ledges properly. Consider using a voxel size less than 0.25. 2 voxels per step height. I am so confused. Try making that again. Okay. How do I limit? Okay, we want to increase this to, maybe we try 1024. And minimum region area is 2. Interesting. Okay. So there we can actually see something. So we don't want voxel size being 1. Try baking that. So it's too much to do that. So 0.5. Let's try, I don't know, 2000. Bake. Nope. I guess I shouldn't have any slopes. 2048. Oh, so that's the maximum amount. We'll include that. We want to include the ground, I guess. So what we're gonna do is go here. Because obviously out here, we don't need, like, a huge amount of, what's it called, pathfinding area. To where, I guess we only actually need the pathfinding kind of for, like, this region right here. Because we can always just make a move towards that. So, what we're going to do is something a little interesting. Alright. So we're going to want to basically just grab all of these objects. Is there like a way to grab all of these? Probably not. At least they're big. Probably want to grab where that tree is as well. Okay. And right now, we only want the ground. So actually, we're going to, I might need to deselect those, but whatever. Okay. Not too shabby. Connect that up. Well, this will be nice to know later for when we actually build the Rio level as well. So I need to make sure to remember about this. So basically what we're going to do is create a layer for these objects. And we're going to call it just navigatable floor or something. Alright, there we go. Looks good to me. Layer. Add layer. Oh no. Of course. Of course. Of course I should have made the fucking whatever. It's okay. It's okay. Oh, how we doing, man? How you doing? This is it. Welcome back. I just went through Unity's documentation for its nav mesh, which is basically, it's, like pathfinding built-in utilities and whatnot. And yeah, so I am currently trying to, see this blue area on the screen? That is like its pathfinding kind of thing. It builds basically like nodes out of polygons. Such like if we get really close, it's kind of hard to see, but there's little lines right there. So it'll build like an area for being walkable, but the problem is that I selected every single tile in this map. And it was too big. I couldn't make it like really accurate. You can see like how in here like the walls were too big. So what we have to do there is I have to basically, I just set up a layer for having a navigational layer, and I'm just selecting all the actual ground objects, which I bet there's a better way of doing this, but I don't really know of one, so I'm just gonna go ahead and do this very slowly. Yes, the nav mesh grid is too big for it to automatically generate, with it like having accurate scaling to the walls. So for instance, if we look at this, like, you see how far away this is from the wall. It's because I set the actual voxel size, which, I don't know why it keeps doing that, which is the, like, size, I think, of the, like the polygons, or something like that, or like and it was way too big, but it allowed me to generate something so I could test and make sure it was working. So basically, now what I'm doing is I'm just trying to decrease that area into a smaller area, because even if we wanted to have the zombie spawn out there, we can just still navigate it to a small point like there, and this area only really needs to, for the actual AI, like nav mesh, needs to only be really, what's it called? For like where they actually need to worry about moving around objects and such. Because eventually we'll have it where like have player placed obstacles and such. Like for instance, these dumpsters, they might be player placed obstacles in the future. But it's all good. We're gonna try this out. If not, we're gonna make multiple nav meshes for specific areas. Okay, yeah, that's a good question. So I'm making the ground, I'm setting it using this layer up here, and in the actual nav mesh like creator, you can specify layers that it's allowed to use. So I'm basically gonna go do this as well for the walls and such, and basically just like make a navigation obstacle layer. Or static navigation obstacle layer, because we'll have some non-static, like, movable ones, which they actually, I was reading the whole documentation earlier, like, we went through, if I pull, I think, this bad boy up, we're going through their navigation, AI navigation, so we went through this, and we went through the navigation system, the inner workings, understanding how it works. Basically creates these nodes, uses A star, which is a pathfinding algorithm. Here's the voxels. But, so I got a little general understanding of it, but of course I might need to reread it if I really want to understand it. But yeah, let's select all this bad boy. And if I miss a space or something, it won't be too big of a deal, because I can just independently select it. So, navigatable ground, and we're applying that. So now, if I just randomly select this, navigatable ground. So next up, we're going to go to the wall, and actually what I can do for the wall is, because the wall will always be some type of obstacle, what we're going to do is add a layer, and we're going to do this as navigation static obstacle. I can't, I'm just going to do OB, because I'm lazy. So here we go, we set that to static navigation obstacle. So now if I select any of these, they'll all be the same. If I go here, go into its prefab, same. And same with these windows. Yes, there's an obstacle layer. I thought, oh yeah, I got stream chat on down here. Last time you did, we had it on last time too, but when you get the big message, pops up. So hopefully eventually we can get more people in the community so everyone can interact and like watch like that. But you know, trucking along. So if we go there, and then last but not least, the doorway. Oh, doorway's already got in it. Okay, cool. So now it's time to try this again. I have a few more ideas to make this work as such. So if we go back to map right here, we can see some things. So include layers, we're going to actually only include static in that. We'll go to advanced. Voxel size, we don't want to override the voxel size, and we don't want to override anything anymore. This actually popped up after I tried to bake the first time. So if we want to walk through this real quick, so the agent type is humanoid. So basically what we're going to do is on this zombie object is we're going to actually go ahead and I think it was add component, and there's a nav mesh agent. So you can see its actual, like, that's the navigational, like, area. So things will try to stay away from it. It has a pre-built-in stuff. Pretty cool. Like steering, speed, angular speed, acceleration, all this. We'll have to figure out how to interact with this inside of our script, movement script. But I think we should be okay. So I'm going to go ahead and just keep that on there because he will need to be that way anyway. So let's try baking. Oh, god damn it. Or wait. Oh, nope, it worked. That worked on out. Sweet. Perfect. I didn't even see it. So yeah, so now we can see the nav mesh, kind of how this is working. This is like a little step up. Oh, now you can see the layer if you really like get down and close with it. So let me see if let's look at that. Because some of the meshes are actually overriding it. So if we get down like this, and let's get underneath the mat and let's look up. This is the way. So we can see here kind of how this nav mesh is working. So now we have a bunch of polygons around this whole thing. One thing I will say, I forgot to change these trees to the static navigation layer as well. And for now, we're going to also set this and this. So Unity automatically is doing this for us. This is just a tool they built. This is why I like using Unity a lot of the time. So we're going to clear that, and we're going to bake a new one. Alright, cool. So there's that, and that does go underneath there. And so you see in baking it, adding those objects, now the new mesh will not, the navigational won't allow it. It did not feel the doorways, yes, because it was, the doorway's too small. So if we click this guy, let's actually see how big of a radius we need for these doorways, because we can specify the agent settings for the humanoid and how big the default radius is. So yeah, if we notice here, his actual default radius is barely the size of that door, causing some finicky things. So if we go down here, agent type, humanoid, speed, rate, obstacle avoidance is 0.5. You can change this per thing, but 0.3 is looking more or less the size of our normal zombie. So we're going to open agent settings, and we can add a new agent. And we're going to call this agent, let's just say basic zombie, like so. The radius is going to be 0.3. And the height is going to be That's a good question. What do we want the height to be? The height, let's say 1.5, 0.6, 1.75 looks to be correct right now. So we'll go here, agent settings, not humanoid, we're going to do 0.3 and 1.75. Step height, 0.4, we're not going to really need to worry about that. And you can have jump distance and drop heights, but we also kind of don't really need to worry about that. So we're going to set that to the basic zombie, and now we're going to try to regenerate that for our basic zombie, which has a little smaller thing. So maybe this will get the doorways. Maybe not. We'll see. We're using the physics colliders. I'm going to try the render messers actually as well. All game objects. Yep. And let's try picking that. Okay, there we go. Now we have an actual little area to walk through these doorways. Using these render messers. And it got a little bit closer on all of our obstacles. So now we have a nav mesh set up. Nice. That's actually, I'm very happy that how simple it was to use and the doorways being like so. So I'm actually going to now place our zombie out here. So next up on the agenda is I want to try to make a goal for him to navigate to. So for now, we're going to make a new 3D object, and we're just going to create an empty one, and we're going to call this the waffle machine. For now, it's not going to have anything. Let's go put that at 0, 0, 0. So if we go over to where it is and grab its location, there's that. So next up, we're going to create a child cube for that. He has a box collider already. Yes, so I'm not really planning on having a random generatable map, and that is definitely something advanced. But basically, if you want to think about it programmatically, there's ways to create a nav mesh surface. So if you were going to generate a map in Unity using something like these tile maps, you would basically just set each layer and then set up something to automatically generate the nav mesh surfaces according to a size. So let's see, like we have a decently okay sized box where you can actually see like the nav mesh height and stuff. But you could actually just create multiple one of these. So for instance, like this area right here could be another nav mesh surface, and you can connect them together. Just the larger ones, I don't think Unity likes that because it's too, because I think they have to generate it maybe when you start the game. I don't know exactly. But it's just for computation. You can like turn on and off the nav mesh surfaces. So they don't want one big gigantic map with a gigantic nav mesh. They want multiple little smaller nav meshes that you can tie together. So for our intents and purposes right now, we don't really need to worry about automatically generating a nav mesh. In fact, we don't even have to really worry about putting a nav mesh out anywhere else, because basically, what's going to end up happening is I'm going to spawn zombies out here, and basically we're just going to select the closest point on the nav mesh on the outside for it to start pathing to. And then once it reaches it, that's where it's going to start actually using that nav mesh for pathfinding. So back to this, we're making a nice, good waffle machine. So this cube is representing basically the goal. One thing I know is this is going to be a damageable object. So if we go ahead and put this bad boy, we'll just put him right here, up against them. And this big cube, it will work for right now. In fact, I might turn on grid snapping, and that makes it a little bit easier to control, like that, like so. It has a collider on it, and we're going to add this to a new layer, and we're going to call this maybe movable obstructions. So there we go. Add that No, we do not need change object layers. And we're going to add a tag, and this is just going to actually be called a goal, because we can always compare to names and whatnot, or we could make a goal layer or such. But right now I'm just going to use a tag as a goal just to get everything set up. So we have damageable component, damageable script, because the zombie, we're going to want him to be able to attack it. So basically the mindset right here is if the zombie spawns all the way out here. Let's visualize this out. Spawns all the way out here. So he's going to start walking this way, basically. And once he hits this nav mesh, then the pathfinding algorithm is going to kick in. And he's going to start probably navigating like so towards this object. But if we, the player, were able to cross into his radius, he's going to forget about that goal and start going after our player. Because he's a zombie, he's stupid, and he knows what he wants, but as soon as brains come on the menu, he's going for the brains. So that is where the mindset is at right now. So we're going to leave our zombie out here because we want him to, of course, start being able to navigate soon. So we're going to also have to update our zombie controller script, our movement script soon. Because right now we have the rotation being basically set to the target. So we don't actually want to set the rotation to the target anymore. We want to set it to the next node, basically, that he's walking towards. And then if he has a target, which is the player, then we're going to rotate it towards that. But that is in the future. Let's learn how to actually interact with this nav mesh. So on our zombie, we have a nav mesh agent component. He's a basic zombie. Base offset is 0. I don't really know what that is. Steering speed is 3.5. I'm going to go ahead and set this to 2. Angular speed, I think that's for rotations. We're going to go 500 again. Acceleration, I have no idea how we're going to use this. Stopping distance, 0. And obstacle avoidance, that's actually just defaultly set to 0. We just defaultly set that to 0.3 and 1.75. Quality is high. Priority 50. Pathfinding, auto traverse off mesh link, auto repath, and area mask is everything. And so basically what we can do is we can set up actual like masks on these actual nav meshes and have different things not be able to walk on different areas. For instance, if we had a don't touch grass zombies, we could even set this area with the grass on our nav mesh to have a different weight or like a different mask. Instead it has grass, so this zombie will walk across grass, but if we had the don't touch grass zombie, then he would avoid that and probably try to just go towards the pass. But that is just a basic example. I actually don't ever foresee needing to use an area mask for anything, really. Basically, the only thing we're really going to be using it for is having movable objects, because I'm going to want the player to be able to set obstacles up in here, and some things as well, just to halt the zombie in their tracks. But that is way later down the line. Let's focus on getting him to move. So let's go ahead and pull this back up. So this, we're going to go back to creating a nav mesh agent. Alright. So once you have a nav mesh baked for the level, it is time to create a character that can navigate the scene. We're going to build our prototype agent from a cylinder and set it in motion. This is done using a nav mesh agent component and a simple script. Okay, cool. So let's first create character, cylinder, game object, 3D object, cylinder. This is just them. The default cylinder dimensions is height 2 and radius of 0.5. So we already modified that. We don't really need to worry about that. And then we added that nav mesh agent already. So now you have a simple nav mesh agent set up ready to receive commands. When you start to experiment with the nav mesh, you're likely going to adjust its dimensions for your character size and speed. Yep, did that. The nav mesh component handles both the pathfinding and the movement control of a character. In your scripts, navigation can be as simple as setting the desired destination point. The nav mesh agent can handle everything from there. Alright, so let's look at this. So we have public transformation goal, and then we have a nav mesh agent equals get component, nav mesh agent, and then agent.set that destination is goal.position. Okay. So create a new, we don't need to do that. So basically now what we're going to do is go here, and we're going to go to our melee zombie controller script. So in here, we have an on start. So what we're going to want to do for a zombie controller, because most of these zombies are going to all have interactions with the nav mesh, we're going to go ahead and do a protected nav mesh agent. There we go. And in our start function, right here, set our agent is equal to get component nav mesh agent. Simple as that. And then agent, and then so this is where we're gonna have to figure out how we're gonna want to set their goals. For now, I'm going to just have select our game object like so, like that. But in a little bit, you will see me change this. Well, maybe not today, but in a future stream, maybe you will see me change this. So here we go. If we go to zombie goal, I'm gonna drag our waffle machine right there. Okay. So save that, and we're gonna go back to our script. And here, what we're gonna do, basically agent dot destination is equal to goal dot transform dot position. All right. So now we're going to comment out the handle movement. And we're going to also comment out the handle animations. And yeah, let's see how that works. So now, more or less, our zombie is taken over by the nav mesh controller. I'm going to hit play. But we're also not going to basically watch our guy. So let's see if this works. I have no idea. Set this shit can only be called on an active agent that is placed on a nav mesh. Okay. So now, for now, alright, we're going to figure this out by putting him on nav mesh. So we're going to have to call a custom script or a custom function on start. Basically, if we want them to spawn outside these meshes, basically you just maybe point a raycast towards our nav mesh, or just path towards the edge of a nav mesh position, and then we set the destination once he's interacting with the nav mesh. So let's try it. He's on the nav mesh now. See how this works. I just noticed something too there. That fire hydrant doesn't have anything. All right, so no errors. And look at that. He is actively moving towards. He's gonna run through that. Yeah. But look at that. He is he's moving himself. That's pretty simple. Okay. Cool. And now he's like, I can't not get there. Alright, so that's pretty cool. So let's get this guy out again. So there's obstacles we can create. So we can put things in the middle. And just, obstacles. A link is basically like a place you can jump across. So you can see that you can actually add those. So that's actually, we're going to probably create links at those windows, and then the condition's basically going to be once the zombie attacks a window or something. So this is the one I really want to get to. So using NavMesh agent with other components. With other unique components too, here's a list of do's and don'ts when mixing different components together. You do not need to add physics colliders to NavMesh agents for them to avoid each other. That is, the navigation system simulates agents and their reaction to obstacles in the static world. Here's the static world is the baked NavMesh. If you want a NavMesh agent to push around physics objects or use triggers, add a collider, rigid body, agent in the animator. NavMesh agent in the animator with root motion can cause race conditions. Both components try to move the transform each frame to possible solutions. Information. Okay, that's not what we actually need. I think we need this interface. Yeah, we need this interface. So here we go. This is how we're going to interface this with the code, basically. So using AI navigation preferences to specify how the navigation meshes, nav mesh and height mesh display in the scene view. The AI navigation preferences are located in the preferences window. To open the AI navigation preferences, do the following. Okay, I don't think I need this. Overlay reference. Don't need that. Navigation window. Probably come back to this later. Okay, so NavMesh agent component reference. This is something we're going to need. Allows you to create characters and avoid each other as they move. The agents use NavMesh navigation through the space of the game to avoid each other and other moving obstacles. You can use a scripting API of the NavMesh agent to handle pathfinding and spatial reasoning. To use, yeah, we added that. Create NavMesh agent for initial, create an NavMesh agent, and okay. Component reference, scripting reference. Definitely want that. Okay. Do we not have a scripting reference? That might not be too good. Here we go. Okay, here it is. This is the documentation for how we're going to use this. So navigation attaches command to a mobile character in the game. Allow the character to use damage. For details, refer to AI navigation. So we have acceleration, the maximum acceleration measure that follows a path given its units and seconds squared. Auto braking, auto repath, traverse off mess, avoidance priority, base offset. Destination has path, height is on NavMesh. So this is where we're going to, if it's not, then we're going to go find that NavMesh and move him. So is stopped, NavMesh owner, next position. So this is where we're going to actually handle the rotation. So he's going to rotate towards the next position instead of rotating towards the goal. So public message, calculate path, find closest edge, get area, move, apply relative movement to current position, raycast, trace a straight path towards a target position in the NavMesh without moving the agent. Reset path clears the path, sample path position, sample a position, set area cost, set destination, set path, warp. Enabled enables behaviors are updated, disabled behaviors are not. So this is how we're going to turn off him if we don't want him using the NavMesh controller, basically. Like if, so basically now instead of setting the target, we're just going to, yeah. This is making me tired. I got up early today and went on a run, did some stuff, and whew, this is a lot. I've never used any of this, so get component, yeah. Alright, cool. So okay. Alright. So we're gonna need all this because we're gonna want some interesting functionality here. Let's pull this out, and we're going to pop our guy off, basically. So let's see what I'm gonna do. We want nav mesh, all areas, add link, calculate path. Find closest edge. Locate the closest nav mesh edge from a point on the nav mesh. Trace the line between 2 points on the nav mesh. Okay, so what I'm going to look up is Unity 3D. We're going to do raycast to a point on a nav mesh from off nav mesh. So to raycast from a point off the nav mesh to find a point on nav mesh, you see ai.navmesh of sample position. This will project your raycast hit point onto the nearest accessible portion of a nav mesh. So, okay. Source position, end position, the end of the ray. So, let's see. Transform, target, nav mesh, hit. Okay, so basically what's going to do is we're going to basically set a list. So here is what I'm thinking. So now, AI for navigation, we're going to expand upon this. So, for AI on navigation, start off nav mesh. So, if off nav mesh, then we're going to nav mesh raycast to the goal. Alright. And at our first collision point, which on the nav mesh, start pathing to nav mesh. Alright. Once on nav mesh, very basic, use nav mesh navigation. If the player enters the, what's it called? The player enters the aggro zone, then switch off nav mesh agent, or actually no, sets the nav mesh destination to the player. So that will account for walls and such for the zombie, so we can't like have some weird, you know, like exploits where the player can like get it to go behind the wall and still walking into the wall but can't get to him. So this is going to have to be constantly updated. Constantly updated player position. Okay. And then next up, we're also going to want if goal/player enters attack collider, disable nav mesh navigation. This will stop him in his tracks. Then re-enable Re-enable. I can't spell. When player leaves. Okay, so that is kind of our basic AI. If we let's think this out. We're gonna pull this to the side, and I am going to pull up Unity and put that to the side as well. So the zombie starts out here with just with not on the nav mesh and knowing basically its position. So basically in fixed update, we're going to have a if on nav mesh, then we use the nav mesh. But if off the nav mesh, we don't set a destination. We activate a raycast function, and then set a point on, like, basically the closest point to the target. So instead of actually walking this way, not like that. Instead of, let me get the zombie. Instead of walking that way, he would now raycast towards the goal object, and he'd start walking this way. And then he would hit the nav mesh. Once we are on the nav mesh, we switch on the nav mesh, and then we let that pathfinding algorithm do its thing. And then we're just going to keep walking towards the goal. Once we get to the goal, he's going to start attacking, which switches off the nav mesh, which will stop him from moving. And once the player enters his zone of radius, we're going to switch that destination to the player's location, which needs to constantly be updated because the player can move around. And so he'll move towards the player. And then once the player moves away from that fast enough, then he will start going back to the goal and start attacking it. So that seems like some basic AI, and honestly, it doesn't seem like it's going to be too hard to set up. I say that before I start programming, of course. Okay, so next up, we're going to basically have to get rid of a bunch of this stuff. So we have agent equals get component, nav mesh agent. We do not want to set the destination yet. Okay. And what I'm thinking is there's going to be probably potentially multiple goals. So, and different zombies might have a different goal. So what I'm thinking is I might actually have a public list of goals. And on startup, the zombies select a random goal, and that's where they're pathing towards. And this way, it allows us to give zombies a complete control over which goals we want them to have. For instance, maybe we have one zombie going after one goal that's sitting in the back here that might be a little more important. But we have another zombie going after this goal, which is generating income or something like that. Or maybe like we have a power thing in the back. Or maybe we have some dumpsters, and zombies like the dumpsters and they want the trash. If they go there and eat the trash, then maybe they get a power up. So we also might set that as a goal or something. So that's where we're gonna do a public list of game objects. Not like that. That's actually the opposite. Of game objects, and I'm in insert mode. Let's not go in insert mode. New list. Public list goals. What seems to be the matter? Okay, we're gonna use using system.collections. Okay, what's that? I guess it's generic. There we go. Okay, so we got our goals. So on start, we're gonna get our agent, and we're going to basically have a function get goal. And this is actually going to be a random function. So what we're going to do here is come here, We're going to do a get a random value from a list, C#. And you can see I've actually like looked into this before. So basically what we're going to do is actually use, so using Unity Engine, so we need to get int goal r size equals goals dot count. Then we're gonna do a int random index idx equals to random dot range 0 and that, and random has problem. We're just gonna use Unity's engine dot random. Okay, and then we're gonna return a goals at random index, and that's not a void. We're gonna have a public so what I'm thinking is actually we're going to put this in zombie controller. This is going to be its first actual function. Oh, all good, all good. I don't even really, is that regex? Like, registers and such? Or like a register execution? That sounds pretty complex and confusing, to be honest. Public game object, get goal. So we have a get goal here. Regular expression, gotcha. Yeah, I have not come across that concept yet. Okay, protection level, it's private, we want protected. And so what is... Oh yeah, that'll do it. Alright, cool. Let's see some errors popping up here. Oh, holy crap. Getting tired. Alright, the same field name is serialized multiple times in the class. Goals. Where are you seeing this? I think that should actually be fine. Okay, so now we're getting a goal from our zombie controller. Validate user input, selecting an IP address or a domain. Okay, gotcha. So kind of like parsing stuff and whatnot. Yeah, I have not dabbled too much with networking quite yet. I did a little bit with like in a class as well, but I have stayed more or less away from interacting with the internet until really now in the stream. But of course, eventually I will have to probably learn all that good stuff. So yeah, we have a goal. I'm going to clear that, and I'm going to just save this again or something. I'm going to just, you know what, get goal, calls that on start. So now, basically, if damageable is alive, so we're going to want to handle our movement. And in our handle movement, we're going to just basically delete this. So if agent dot is on nav mesh, then move with nav mesh, else, then next up what I want is we're going to do basically we can set a target to a game object, because our target is a game object right now. Right? Target is a game object. So, let's see. Oh, wait, yeah, we're targeting to the goal. So that's the position. So basically, let's go back here, and we're going to actually re-enable all this stuff, because we're going to basically move towards that, not target, but goal. Goal.transform.location. So we're going to delete this, and this is actually going to be else, because if agent dot is on nav mesh, then we handle nav mesh movement. Okay. Okay, so now we have else if goal is not equal null. Then we move towards the goal. Else rb.position, or else what we're going to do is moving equals false. Okay, there we go. So now, let's see our handle rotation script. So not if, so let's first of all handle this nav mesh. So if target does not equal null, then we are going to basically set agent dot transform dot or not agent, where agent dot destination is going to equal our target dot transform dot position. Else, we're going to do else if agent dot destination does not equal goal dot position, goal dot transform dot position, so if target does not equal null, then we're just going to set our agent to go towards the target, which is going to be our player, basically. But if that's not the case, then if the agent's destination does not equal the goal location, then we're going to set the agent's location to that goal location. Okay. Okay, cool. So we should always have a goal, because we're going to get goal from our zombie controller. Get goal, return goals. And our get goal is actually going to do goal is equal to get goal, which is good. Okay. Wait a second. And I'm looking at this random range goal.size. Well, not -1, right? Or no? Yeah, we want -1. Because right now we're not even half of the goals. So if I'm thinking this through right now, so we're handling the movement if we're alive, of course. If we are dead, we're going to set the, going to basically just turn off. So agent dot enabled equals false. If we're dead, of course. So we stop moving. So there we go with that. Okay, cool. So let's see what that does, actually. I'm very curious. Oh, wait, didn't add a goal, so it's not going to have a list of anything. So I need to add that error handling. It's going to pop up with a bunch of errors right here, right? Yep. Okay. Zombie. Variable goals. We're going to add that, and we're going to put a nice little waffle machine in there. Okay. Index was out of range. So if goal does not equal null, RB position, agent is on mesh, else if goal is not equal null, then we move towards that goal's position. Because I don't plan on having any obstacles in the way outside of the nav mesh. Right? Cool. Now that we have our goal position, let's check this bad boy out. And then after that, I am going to go use the restroom because I am dying internally. Alright, so he's moving. He's not rotating, of course, so we don't have the rotation set correctly. And now he is on the nav mesh. Let's see. Okay. Did not be able to create agent because it's not close enough to the nav mesh. Okay, gotcha. Yeah, I am dying internally, exactly. Yeah, I will be right back. I'll leave you with the music. Alright. Alright, we're back. Sorry about that. So let's see. We got a little warning saying the agent failed to create agent because it's not close enough to the nav mesh. Alright, so that means we're creating the agent, which is... where is that being... Okay. So what we're going to basically do is... So where is that coming from? We're going to debug log the agent. I just want to see what that does. Zombie nav mesh agent. Okay. So how close does he need to be to the nav mesh to actually see if this works? So I think that just started working, actually. Yeah, there we go. You just walked on by. So if we go over here, he's gonna actively start following me, like so. But if I run away, okay, he never. Oh yeah, because I never unset the target, of course. Okay. So if I go hide behind this, let's see how he reacts to that. Yeah, look at that. He is pathing right towards me. Just like so. Very nice. And he starts beating the crap out of me. Nice! Okay. So that's close enough. But I do want to be able to spawn him pretty far away so we can have time to prepare. So put agent dot current off mesh link data desired velocity destination equals game object has path height hide flags is active and enabled is path stale is stopped. Okay. So this is where ask the nice internet. Unity 3D agent is, what was that message? Set them all the way out here. Oh. What the heck? He's already there? How's he already there? Whoa. That was kind of crazy. What is he doing now? What you doing, dude? Wonder what's going on there. Maybe his collider? Nope. Okay. Very interesting. Oh, and now the model's off-centered as well. That was very peculiar. Alright, so now that he's close, let's see what happens. Okay, so he basically just teleports to the location, interestingly enough, which is RP.position. Why was he teleporting to this position? Let's try a transform position instead. Oh. It's teleporting. Weird. So I'm gonna try putting him pretty far away over here in this grass. See what happens then. Okay, so yep, failed to make agent because it's not close enough to the edge. Alright, so let me copy this. And let's do a little bit debugging. Closest hit 501. So we basically add the component like so. Okay. That mesh hit, closest hit. That mesh sample position, out, closest hit. So this is basically like a ray cast. Okay. So we'll have to force go on the nav mesh. Place the same go as the nav mesh agent. Using Unity Engine.ai. That should already be, that's already baked in there. Okay. I'll also set it's moving to true here. Okay, let's see. Target does not equal null. So I'm going to do if is attacking. So we're actually going to set agent dot enabled is equal to the inverse of is attacking. Of goal does not equal null. And not is attacking. Handle animations going, handle rotation. Oh. So we'll go here if target doesn't equal null. So this is actually going to be deprecated. But if agent dot is on nav mesh, if not is agent is on nav mesh, and the goal does not equal null, then we're going to actually just rotate bar direction equals goal dot transform dot position minus transform dot position normalized. And now we're going to literally just copy and paste this. I'm also thinking about the positioning of the attack collider now for the zombie, because this is rotating the character's model, but anything that only rotates anything that's a child of the character model as well. So this attack zone is actually not being rotated with the zombie. So we're gonna actually put that. We're going to open up our zombie. Or actually, first of all, we're going to override all. Apply that to all. And we're gonna go in here, put our attack zone underneath that guy, because now the attack zone will rotate with our guy instead of staying that direction. Okay, cool. Finally, we need to handle, what's it called? Our agent being created. So, how far? Nav mesh agent, Geekman, nav mesh as nav mesh agent. Okay. This is always fun. Okay. I'm going to look for some guidance from ChatGPT. Alright, so in Unity 3D, I have a zombie controller script which uses the nav mesh agent for pathfinding. However, I want to spawn the zombie game object away from the nav mesh. If it is too far away, the nav mesh, the agent will never be set. So I want to Basically, I want to be able to, I want to check to see if the agent is set, is okay. What was that error message again? Damn it, it's gone. Hit play. That is created, and if not, then we keep trying to create it until we are close enough to the nav mesh. Here is the warning message I get. Alright, we're going to see what it does. I don't want to copy and paste it and give it my code, because it was going to mess up everything. So initial placement check. Close enough, sampling the position or near the nav mesh. We try logic. If the nav mesh agent fails to initialize, attempt to move the zombie closer to the nav mesh. For sampling, use nav mesh sample position to find the closest valid point on nav mesh. Yeah, this looks like a bunch of bullshit. So basically, what I'm seeing is I just need probably to eventually expand this nav mesh. I wonder. I'm not really going to worry about this right now, because this sounds like a future me problem. Ay, ay, ay. Ay, 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 dude. This is gonna be rough. But on the bright side, looks like we're, what's it called? Moving now. Watch this zombie. He's pathfinding towards the door. Walks in, goes towards the thing. But we're going to, like, no, dude. Don't go towards there. Now let's see if he stops moving and attacking. So if he's attacking, we need to change the rotation, basically. Because right now he's rotating the opposite direction for some odd reason. Smack. And he's not moving. Alright, well that is some basic AI navigation setup with a little goal object like so, which we cannot move right now, but eventually we will be able to move it. But yeah, so I think I am going to go ahead, give it a little break, probably come back tomorrow, probably hopefully a little bit earlier, a little less tired, but yeah, see, give it about 2 hours of stream. I'm okay with that today. It's been a little tiring day. I hope you enjoyed the stream. I think I will probably be... Oh, one thing I'm now noticing is where's my cursor object? Why is the cursor not working? Oh boy. This is something I have to fix right away. Cursor. Let's see. Ground. We need to get a layer mask ground nav. Yeah, this is a very simple fix. Let me just go ahead and stop this, and I'm gonna fix that, and then I am going to stop working on the game for today. If you want to hang out, we're gonna probably be playing some games here soon. We take a little computer break and then probably play some Sea of Thieves. We played that again last night, had some chaos. Lost our boat, navigation static orb, navigation. Okay, we're gonna go to add layers, and I am just going to copy and add that to the layer mask, like so. And now that will work. Correct. Also, I am currently trying to set up the Discord. Yep, there we go. Cursor's back and working. I got like the basic thing set up, but I want to get it kind of fleshed out first. Before I start like actually inviting and sending things out. Yeah, no, absolutely, you're good. I'm actually happy you're here too. Whoa. Whatever, we're gonna deal with all these things tomorrow. 20 minutes? Jeez, sorry. That's crazy. Well, it is really late there. That's nuts. Well, I'm happy you are staying up that late to tune in. I hope providing some entertainment, some inspiration, and glad you're here. Definitely, I'm working on getting that Discord set up. I will 100% let you know when that's set up and populated. I want to get some like bots in there, of course, and make it more of a fun place rather than a barren wasteland with no one in it. So, yeah. Alright, dude. Appreciate you guys hanging around. Hope you enjoyed. And just remember, the good's always out there. Just one step away. Take care.